Welcome back, everyone. In this lecture, I want to give a quick overview of the MNIST dataset we'll be using in the next lecture. This is a classic dataset in deep learning, and it's known as the MNIST handwritten digits dataset. I want to quickly cover some basics about it since we'll be using it quite frequently during this section of the course to understand the difference between artificial neural networks and convolutional neural networks. Now, fortunately, this data is really easy to access with PyTorch Vision, and we're going to end up downloading around 60,000 training images and 10,000 test images, and we'll talk about that later on in the next lecture. But let's actually talk about what the data itself looks like. The MNIST dataset contains handwritten single digits from 0 to 9. So there's 10 total classes, 0, 1, 2, 3, all the way up to 9, and they're all handwritten. And a single digit image can be represented as an array. So here we have all the images represented as an array of 28 by 28 pixels. So if we were to look at just a single image file, we would see that we have here the number 1 drawn, and everything's organized as a 28 by 28 array, where we have white as 0, and then the darkest color is black as 1. So we can see it's normalized, so all the values fall between 0 and 1, and then it's a grayscale image. So the values themselves represent that grayscale image. So we're first going to explore how we could approach this dataset with a standard artificial neural network. The idea behind this dataset is if you were to then, after training on this dataset, draw a handwritten digit, would your network actually be able to classify that handwritten digit correctly? So that's what we're going to be using the test images for. Now, in our case, since we're using an artificial neural network, we're going to need to flatten out that 28 by 28 array to 784. So to give you an idea of what this would be, if we were to take a look at that other array, what we're going to end up doing is essentially concatenating all the rows together so that we would get something like this. So we have kind of those zeros at the beginning, and eventually we kind of concatenate all the rows together so we have one long flat array of 784 inputs. And it's 784 because 28 times 28 is 784. So after we flatten that out, what we're going to do is we'll feed it into that first input layer of 784 neurons. And then we'll go ahead and have some hidden layers, and at the very output layer, since there's 10 total possible classes, 0 through 9, we'll go ahead and have 10 output neurons. And we'll end up using some cross-entropy and softmax loss functions in order to have each neuron output a probability of belonging to that class. And we'll use some one-hot encoding later on in the next lecture when we actually talk about how to implement this with PyTorch and programming. Now, keep in mind that flattening out that image will actually end up removing some of the two-dimensional information, such as the relationship of a pixel to its neighboring pixels. And for now, we're just going to ignore that loss of information by flattening it out, but we'll come back to it later when we discuss convolutional neural networks in depth and why they're actually a better approach for images. But for right now, let's go ahead and try out using an artificial neural network on this data set. I'll see you at the next lecture.